I'm gonna go to Desmos. Oh, great. There's no website. Okay. It doesn't have a block Desmos. Do they block Desmos? No? Let me try it from here. Okay, it seems like they block Desmos. I don't know why they block Desmos of all websites. Okay. So I'm gonna show you that y equal to the sine of x. I think a lot of people didn't understand that. And I'm gonna show you y equal to sine of negative x. So that's gonna be opposite. So therefore they are odd function. If you plug in negative x, it's gonna give you negative sine of x. That's an odd function. But if so let's just say y equal to, let's just say, get rid of this. Y equal to cosine of x, right? Versus y equal to cosine of negative x. Now you see they are the exact same graph because cosine of negative x equal to positive cosine of x. But sine of negative x is equal to negative sine of x. Does that make sense or no? So they are basically, there are four different graphs here, and that's the things that you have to study is to understand why there are symmetries. Now, I'm gonna go back to write down for you so that way you know. If you have sine of negative theta is equal to negative sine theta, and the cosine of negative theta is equal to cosine theta, because this is even and this is odd. You can tell from the function, even odd function, also from here, this is odd because they are symmetry to origin. And this is even because they are symmetry to y-axis. So therefore, you can tell the symmetries. Okay, and then if you can tell the symmetry, you can eliminate those polar, you can eliminate those things. We're gonna go through a couple of examples. So first example that they give it to you is r equal to 1 minus cosine theta. So the first thing you want to test polar axis. So what do we talk about if symmetry to polar axis? Well, which side is polar axis? The x-axis or the y-axis? X-axis? Good. So if you are change that, it's gonna be, you're gonna replace the data with negative data, right? So it'll be r equal to 1 minus cosine of negative data. That's r equal to 1 minus cosine of theta, because negative data is going to change the past. So this is symmetry to the polar axis. Now you gotta test other one as well. So let's test the other one. What's the other one? You test for theta equal to power 2, which is y-axis. That means you have to replace both r and theta. So I'm going to replace that. So it's going to be negative r equal to 1 minus cosine of negative theta. So whatever it is, I'm going to change in red so that way you know you replace that with the negative theta. So negative r, negative theta. Now this is what I replace. Now that's going to give you negative r equal to 1 minus cosine of theta. if you distribute if you multiply everything by -1, so it's going to be -1 plus cosine theta. Is that the same as the original equation? Is that the same? No. So if it's not the same, then it's not symmetry. Ian, wake up. Okay, now last one, you want to check, are they symmetry to, so not symmetry, right? Not symmetry. And you're going to check it, are they symmetry to pole? What is the pole you replace? You replace a R with a negative R. So that's it. R equal to negative R. So let's write down the question. I'm going to replace R equal to negative R. It's going to be 1 minus cosine of theta. If you distribute that, it's going to give you 1 plus cosine theta. Same situation as before, so it's not symmetry. So when you graph this, right? When you graph 1 minus cosine of x, r equal to 1 minus cosine theta. And let's just say you graph by hand. I don't know if you guys tried to graph by hand yesterday. But if you graph by hand, if you just do it to pi, so if you just do it to pi right here, it's going to give you half the graph. And then if you have that symmetry idea, you already test the symmetry, you know which side is a symmetry to. So you can graph this half and then just copy it to the other side because that's a symmetry. Does that make sense? You can graph halfway, so just plug in pi over 4. If you plug in certain things, that is going to go in. Yes.
Make it the limitation, so it's going to pi.
Yeah, you can. So, can some Neil, can you show her how to do that? Because she wasn't here. Huh? You didn't. Why didn't you ask me a question yesterday? How many times I told you guys you have to ask before you leave? It doesn't matter what kind of students is. You should understand how to do something before you leave the classroom. Okay. Well, next time, make sure before you leave the classroom, you have to understand. Now, Neil is a good student, but I'm going to give you a hard time. So is Safa. It's a good student. I'm going to give you a hard time. I don't care about what kind of student it is. If you don't understand something, even a good student is going to be more accountable. You should understand before you leave. Okay, so bad student, good student, it doesn't matter. You need to be not afraid to ask questions. Says, look, I still don't understand. Can you explain this to me? One of my favorite students from second period is Julissa. Julissa's always asks me, says, hey, I need to understand this before I leave. That's fine. I'm not going to be upset. I'm going to be very happy if I see that. But if you don't understand how to do something, please understand before you leave. Yes. You can. So you're going to plug in. So what are you going to do? Okay, so what happened is I'm going to tell you how to do that. So those of you guys have calculator, get your calculator out, graph R equal to 1 minus cosine theta. And change the window. The theta min change to 0 and theta max change to pi. There's a way to enter pi into your calculator. I don't know where that is, but click that. Right, there's a pi button, right? I think. So you're gonna see theta min and theta max. Then you only graph half the paddle. If you still don't understand, I'm coming around to show you. You got it? Okay, can make sure your table got it. Yeah.
On Friday, did you see like a pink ball?
Okay, Neil, you got it? Okay, make sure you understand it before you leave. Yeah, you can do it without calculator. We can show you how to do that. So some people are asking, is there a way to graphic calculator? You need a polar coordinate. So you need to have a polar things on your table. So let's just show you the polar here. That's gonna be like right here. Hold on, let me see if I can put it. Oh, this cannot do it. Okay, so you're gonna plug in 0 into the cosine data. 0 cosine data is gonna give you 0, right? So you're gonna plug in the first point, which is the 0 right here, the 0, 0. And you're gonna plug in the second one. So let's just imagine you plug in pi over 4. If I plug in pi over 4, what am I gonna get? 1 minus cosine of pi over 4, which is 1 minus square root of 2 over 2. What is 1 minus square root of 2 over 2? Anybody can tell me what's 1 minus square root of 2 over 2? So 1 minus square root of 2 over 2 is 1.4 divided by 2. So it'll be 0.7, so it'll be 0.3. So if you see here, is roughly 0.3 away from the center. Because you see this, you have a one radius, look at a 1. So 1 radius is that 1 there, so 1, 1, 1, 1. That's 1 radius. 0.3 is where that intersect, the red and the black. And if you graph each one, let's say you graph pi over 4, you graph pi over 2. Imagine you graph pi over 2. It's going to be 1 minus cosine of pi over 2. What is 1 minus cosine of pi over 2? 1, right? So you see this intersection is at 1. Do you see that, Armin? What? So I'm going to take a screenshot here. Right? So let's just imagine that we have this. We have theta, we have r, and the theta is going to be pi over 4. So it will be 1 minus cosine of pi over 4. And that's equal to 1 minus square root of 2 over 2. And that's 0.3. So this is 0.3. This is 0.3. This is pi over 4 and 0.3. Why? Because this is 1. So it's 30% there. Now if you plug in another pi over 2 here, then it's 1 minus cosine of pi over 2. So it's 1. So that's going to be a pi over 2. Here's pi over 2. And that's 1. So it's polar coordinate. You're going to plug in each individual one. And let's plug in 3 pi over 4. So 3 pi over 4 is what? 1 minus cosine of 3 pi over 4. I have no idea what's that. So it's 1 plus square root of 2 over 2. That's 1.7. So you're going to see here, this is a pi over 4. 1.7 is bigger than first ring. So this is a 1. And 1.7 is right here. Do you see that? And each individual, let's say it's to pi. So it'll be 1 minus cosine of pi. So that's going to be 2. So that's why you get 2. So you got all this point right here, and you connect those points. And then you draw a symmetry based on that, because you don't have to do a rest of the point because you already find the symmetry. So you can do 0 to pi and just find out what symmetry is. Then you can graph the other side. So what happened with the other side? You're going to come out. You're gonna say, well, if I graph the other side of symmetry, so it's 2 pi, you finish the graph the whole thing. And that's how you sketch the graph from the original state. Now, most of you guys, I just want you to use technology. It's very tedious to graph points by points by point. But you do need to know how to graph polar coordinates. Basically, there are a few polar coordinates you plug in. Does that make sense? Now, what we're gonna do is we're gonna see other type of graph. So let me show you what other type of graph of symmetries. We're gonna show you what is r equal to 1 minus 2 sine theta. What if I have r sine 2 theta? Is this symmetry to what? Right? The first thing, you replace the theta with negative theta. Ian, wake up, stand up, or get out. I'm not in a good mood on April. If you're gonna see me, I'm in April, I'm in a piss off mode. Because that's a month before the AP exam. But if you're gonna play your phone, I'm gonna throw it out a window. I just throw Bennett's phone out a window. And after I throw that phone out a window, when I take it back, I'm gonna unlock it the whole day. So you cannot use it the whole day. I'm gonna press the password just an infinite amount of time. You really want to cross me? This is how I'm gonna treat you. Because this is a month to help you grade from a good, decent, from a bad grade to a decent grade. I'm trying to help you, but you gotta be here, and you gotta be able to work. And if you not work, don't come here. Because I'm not a nice guy at April. I want to make sure you guys all get a 5 on AP exam. I don't want a 3, I don't want a 2, I don't want a 1. So what happened with this, you're going to replace the data with negative data, right? That's the first thing you test. So replace the data with negative data. So if I replace that, it's equal to 1 minus 2 sine of negative data. And r equal to 1 minus 2 sine of negative data is going to give you, this is an r function. What happens if you plug in negative data? It becomes positive, right? Negative times negative is positive. So sine of data. Now, is this the same as here? No. So it's not symmetry. Now, I'm going to replace that with r, with a negative r, equal to 1 minus 2 sine of negative data. So that is going to give you r equal to 1 plus 2 sine of data. Is that the same? Yeah. So I replaced the r with a negative r, right? So that's going to give you here, right? And I replace the 1 minus 2 sine of negative data. This negative data becomes positive, so 1 plus 2 sine data. Is this the same as here? No, so there's not symmetry. So no, no, no polar axis, no, yes. You multiply both sides by negative sign. So no to theta equal to pi over 2. Yeah. What? -1, yeah. -1 plus 2 sine theta, yeah. So, but that's not, still not the same. That's actually completely opposite. Thank you. So it's no to polar, no to theta equal to pi over 2. Now we're gonna replace the last one. We're gonna say, we're gonna replace the -r. So -r is equal to 1 plus 2 sine theta. R equal to -1, -2 sine theta. So there's no symmetry at all to anything. Now, if you graph it, you're gonna find some type of symmetry, but pay attention how it is. So if I graph this function, it says R equal to now I'm just gonna do it to pi over 2, and you're gonna see there's a symmetry, but pay attention to what happened here. Is a symmetry if we go to pi over 2 and to pi, to pi. If I do symmetry, it's gonna be exact same graph to y-axis. You feel like they are symmetry to y-axis. They are not symmetry to anything. Because if I do 0 to pi, they only graph the other side. Now, if it's symmetry, they were gonna repeat exactly the same thing. If it's symmetry to x-axis, it's gonna the other side. It's gonna form like almost like 8 shapes, right? And if you symmetry to origin, I don't even know how to graph symmetry to origin. Symmetry to origin is gonna be like an 8 as well. So this actually no symmetry. You're gonna feel like this has two symmetry, but they are not. If you go into like this, there is actually no symmetry. It seems like a symmetry to y-axis or theta equal to pi over 2, but it's not. Yes. 1 plus 2 sine theta. Oh, it's supposed to be, yeah. But doesn't matter what, it's not symmetry. 1 minus or 1 plus. Let's do 1 minus. My fault. It's just the other way. But still no symmetry. It appeared to have a symmetry if you graph 0 to 2 pi, but it doesn't, because if you go to 0 to pi, actually it doesn't show any symmetry. If you symmetry, then it's gonna form the other side of the petal, rose petal, but it's not. And one rose petal is smaller than the other one. So they are off. They are not symmetry. Now you're gonna say, what is the symmetry to polar axis look like? So let me ask you those two questions. Which symmetry are they? R equal to 4 sine 2 theta. It will appear to have one type of symmetry or two type of symmetry, but it's only symmetry to one kind. Okay, the second one I want to ask you is R squared equal to 4 sine 2 theta. What kind of symmetry are that? So you guys work it out. Which symmetry are they? Figure out which symmetry are they? First data, we're gonna replace data with negative data. So be r equal to 4 sine of 2 negative data. So is equal to 4 sine of negative 2 data. That's going to be negative 4 sine of 2 data. So that's not a symmetry, right? Now I'm going to replace r equal to negative r and data with negative data. So that's going to be negative r, 4 sine of negative 2 data, but negative r equal to 4 sine of 2 data negative. So r is equal to 4 sine of 2 data, which is same as before. So this is actually data equal to pi over 2. So this is a yes, this is a no. And then you're going to replace r equal to negative r on the last one. So negative r equal to 4 sine 2 theta, and r equal to 4 sine 2 theta. This is a negative. So there's only one symmetry, which is at pi over 2. But let's graph this. 4 sine theta, right? See, they are symmetry to y-axis, which is theta equal to pi over 2. Because you go to 2 pi, they will repeat itself. But you're going to be like, wait, are they symmetry to x-axis? No, they're not. Because if you do 0 to pi, right? 0 to pi is like this. If they are symmetry to x-axis, it's going to be the exact same thing. So they are not symmetry to x-axis. They are symmetry to y-axis, because if you graph halfway, only show right side of half. Does that make sense or no? Okay, we find out is symmetry to theta equal to pi over 2, right? So if I just graph 0 to 2 pi, I can reciprocate the right part of the graph and just do this reflection image to y-axis. Then they will give you this, right? But when we test it, you're gonna say, well, this looks like it's symmetry to x-axis. It doesn't, because if I do 0 to pi, then it's symmetry to x-axis, just basically the same paddle and copy across the x-axis, which is not true. But it appeared to be both, but it is not true. Okay, you cannot have symmetry to two things. Now you're gonna say, well, is anything symmetry to origin? Well, it's possible. This is the case. If you plug in r with a negative r, right? Square, guess what? This is r squared equal to 4 sine 2 theta. So therefore, this one is symmetry to origin. And you can see that r squared, 4 sine of theta, I think. Oh, they don't graph like that. They don't graph square for weird reason. I think they might do this. R square is plus minus. So it's plus minus. Let me see if I do that, it'll work. Maybe it doesn't work. Equal to. So they don't graph the r square, but they do graph r's equal to 4 square root 4 sine theta and 4 sine negative 4 sine theta. And this is called symmetry to origin. This is symmetry to the pole. It looked like infinity sign, but it's vertical. Okay. Now we finished talk about polar graph. Now on your exam, On your multiple choice, let's look at which question are they. Question on the polar, but we talked about it. Any questions here? Yeah. So now we finished with that. I want to review something though. Is how do you change polar function to the thing? So we did that before the break. So I want to make sure you guys know that. So what would be the polar function? So polar function you need to know is x equal to r cosine theta, y equal to r sine theta. You have to know this. And tangent theta is equal to y over x, and x squared plus y squared is equal to r squared. So those are the things that you need to know for polar equation. What else you need to know for the things that is really related to this is a complex number. So complex number z equal to a plus bi, or z is equal to r cosine theta plus r sine theta I. So this is called polar form. So this, Lena, this is what I need you to write down for the, I'm gonna make a cheat sheet and Lena's supposed to help me. I don't know if she will. Basically all the things on the cheat sheet, I'm gonna ask her to put in PDF file and I'm gonna give it to you. But this is one of the things that I will put on the cheat sheet. So that way when you study before the exam, you have something to go to. I have a cheat sheet for Calc 1, I have a cheat sheet for Calc 2. I don't have a cheat sheet for pre-calc. So we are gonna collectively do it together. This is one of the things that you need to know. So you can convert the complex number to polar form, but basically use the polar ideas. Now, so this is gonna be cheat sheet material. For the polar. Now, you're gonna say, well, how do I convert certain things? So, let's just say r equal to 5. Do you guys know what this graph look like? It's a circle with that radius of 5. So you say, okay, well, how do I convert to a rectangular equation? Can I square both sides? What happens if you square both sides? So let's start with r equal to 5. You can square both sides, r squared equal to 25, right? And can I say it's r squared? Look at the equation. What is r squared equal to? X squared plus y squared is equal to 25, right? So you just convert to rectangular equation. You start with the polar, and you convert to rectangular. And that's a circle with the radius of 5. Is that going too fast? I can square both sides, right? How about theta equal to pi over 4? How do I convert this polar equation to the rectangular? It turns out it's actually not hard at all, because what's the only one that deal with theta here? Look at the first 4 equation. What's the only one deal with theta? Tangent. So can I tangent to both sides? What's tangent of pi over 4? 1. What is tangent of theta? According to the polar equation. Y over x. Guess what? Y equal to x. That's a rectangular equation. I went from theta equal to pi over 4. I convert to y equal to x. Any questions? Okay. So remember, you got to learn how to make adjustment to this. So r equal to 3 cosecant theta. What do you think in rectangular is? Rectangular is going to be x and y's. So how do I convert x and y? What's a good idea for doing here? Any good idea I can convert this to x and y? Yes. Convert to sine. You are really smart. Why? Because r equal to 3 sine theta. Does that make sense? Can I move the sine theta to the other side? And what is r sine theta? Y equal to 3. So look at it. R equal to, let's just say r equal to 3 secant of x. 3 cosecant of x of the theta. And if I graph that, I got a straight line at 3. Look at this. I got a straight line at 3. Even though it's polar equation, you know, it's always like circle, circular, but it's not. It's actually 3 cosecant theta. Does that make sense or no? But you changed it, somehow use any of those 4 equations, you convert to the polar form. How about this one? R equal to -6 cosine theta. This one's kind of tricky. What can I do here to make the rectangular? Well, how do I hit 2 per 1 stone? Because on the left side is r, right? But r cannot convert to x in terms of x and y. But what can? What is it? No. R cosine work, but how do I make r cosine happen? R squared. How about both ideas? How do I make r squared and r cosine happen at the same time? There we go. Good job, Ian. That's one time I need you to stay awake, and that's good. So r squared equal to -6 r cosine theta. Why? Because you had 2 per 1 stone. Because r squared is what? X plus square y squared. And what is the r cosine theta? And there you go. You just convert it. And matter of fact, on your SAT, you're gonna have something like this: is how to complete the square. So I'm gonna show you how to complete the square. You're supposed to be x squared plus 6x plus y squared is equal to 0. And you need to complete the square. You're gonna take this term divided by 2 square. So that's gonna be 3 squared. That's equal to 9. So what happened? You're gonna be plus 9 and a plus 9 on this side. So here you're gonna have x plus 3 squared plus y squared equal to 9. What does that mean? That means you have a center at -3, 0, and this is r squared, so radius is equal to 3. So today's homework, you're gonna have some conversion to do. I'm gonna show you how to convert from rectangular to polar. I'm gonna take a picture of the notes. You can do that. But this is a major part, is can you convert the polar to rectangular, rectangular to polar, equation-wise. So this is the thing. We are gonna have another 2-mark exam, but after, probably by tomorrow, we're gonna start going over all the mock exam. We're gonna start going over the one on Saturday. And then when we go over on a Saturday, we're gonna create questions based on each question we go over. So on question 1, we're gonna list down probably 3 possible we can ask the same question. Question 2, we're gonna do the same thing, and that's gonna list down as a homework for you to practice. Now, a lot of people are concerned with the FRQ. A lot of people, I think Brendan got 35 on the MCQ, says, well, FRQ, or Armin says FRQ is really bad. It's not. It's something that we covered before. So if some people can get 35 out of 40, that's great. Some people got 20 out of 40. It's okay, because I think you only need 24 points to get a 3, which is very, very low. Total point is, I think total point is, MCQ is 40, and the FRQ is 9 point each or 6 point each. I don't remember. But you're gonna get the result of the score, and then we're gonna grade it together. And that way you can see, okay, this is what question is asking, how the question is asking. But all this question, I think 3 FRQ, it should be pretty easy. One with the exponential rate, exponential growth equation. That one might be slightly hard, but that's just something we've done before too. It's not something new. Okay, that's all for today.
Like you're starting in the middle of class. I was like, I want to go to the bathroom and clean this up, but I don't want to go and do this today. What did you want me to do? I said they might ear start bleeding.
You played the 71%.
I don't know.
Ellie, you're slow as I know.
Hey, at least my brain,
Move your butt.
my brain is fast.
Your brain is fast? I don't know. So we can, if you the multiple choice, I'll put up by period first. So Adam, Anderson, Lisa. So this, go ahead and help me distribute the young.
There you go. That's why all of it is scary.
Okay. So
And you have all the presents. That's the first time.
I won. He's not here. Sorrow.
I simply know it.
Sorrow. Alvin, Jordan,
Hey.
Guys, I'm a
Tranquilo.
Yo te tengo. I started guessing. Like, I think, so like 40, I just started guessing.
Yeah, I know. Let's see the new one.
Balance store. Chase. Aiden. Paulson. Brady. Kevin.
Tranquilo.
I don't think it's
Jay. Josh. Omar.
Hey. Tranquilo, papi, tranquilo. Basta.
It starts off easy and they get it bad.
Oh my gosh, this one?
Jimmy.
I have no idea what I'm doing. Yeah, kind
You know what I did? Instead of doing pi r squared, I did pi t squared.
Oh, I do. You know why? I'm like,
So you did.
All right. Nice day outside. All right, so summation. You should have summation homework done. Luke, do I need to call your parents? Huh? I might need to soon.
You got
Either they beat your ass or I beat your ass. But I get arrested if I beat your ass.
Same thing happens every time. You start saying this.
you got to look how drive.
Hell.
Luke don't know how to drive?
Well,
No, you drive with a ping pong table.
Yo, he stopped at a light, making traffic. What he's doing? He's like,
What the?
Something is important to me. Something is more important than that.
It's people like you that make me scared to get on the road.
I wasn't flirting.
Well,
In my lane.
he's probably better driving than I am.
I had like really a second and a half. Like everything
Yeah,
was
I
great,
don't
Oh, is it? Seven is just.
All right, so here's the answer, so that way you can check if you did it right. Now, put in mind this only happened around 40 or 50% of the time. It will happen once. So it happened last year. So I didn't want it to be like last year. I was kind of mad. Like people just coming to me is like, Mr. A, how come you didn't teach this? Well, I said if I teach it, I don't have time. But this I actually have time. So I said I'm gonna go through it. Last year I only teach it a good student. Some good student remember it. So only like 3 students remember how to do this. But anyway, this is gonna be between 2 to 5 x squared dx, and of course you can evaluate this. The second one is 4 to 6 1 over x squared dx. The third one is 3 to 4 square root of 1 plus x dx. Now this one's kind of tricky. This one is, see that it's 1, 2, 3, all the way to n. And this is a delta x, so that means the a to b is exactly 1. But where do I start? Well, I start with the a. So a plus b plus delta x I is right here. So therefore is 1 plus 1 over n I. This is 1 over x. This is 1. This is 2. Integration from 1 to 2 of 1 over 2 dx. The next one, it's going from 0 to whatever. What? You see it's 1 over n. That means it's between a to b is 1. Right? But it also doesn't give you a to start with. So a is 0. So then you got I over n here, and you got something function square because you've seen everything is square. The one thing that's kind of confused for students is that n minus 1 over n. Now in that particular case, this just means the left endpoints. You're gonna use the left endpoint instead of right endpoint, but I mean with that, I don't really care if you like comprehend it, but all I need is just between 0 to 1 x squared, which is you can get without a n minus 1 over n. The n minus 1 over n is kind of confusing because it's using left endpoint rather than right endpoints. Now, I think on the BC test, it's gonna show up this format. On AB test, I have seen show up this format before. Now, this is the rest of the thing, so you can check. It's pretty much repetitive.
It's just like
No, this is not very important. So if you don't understand, it's not end of the day. So we'll go over multiple choice. That's more important. This is only happen 40% of the time. It will happen on the AP exam. So that's like 1 out of 2 AP exam that happen 1 question MCQ.
Mr. A, number 13, why is it pi x not 2 pi x?
Why is 2 pi x?
Oh, it's just on our paper, it's so in my exam, which is going to be 1 over n. Like, once it's 2, so that's
Huh?
For number 9, what's the A?
MB is from 0 to 3. 1 over root x. Now, like I said, this is if you don't get it, it's not end of the world. We're gonna go to MCQ. I just want to at least you guys exposed to it. When you see it, at least you know roughly how do you start. Usually figure out what A's and B is, right? Figure out what A, B is, and figure out what a delta X. Once you figure out the delta X, you can figure out what A and B. And once you figure out A, B, you should be able to figure out the function. And then just integration of function, that's pretty much it. But that's all the work for this one. I'm not gonna spend more time on it because I don't feel like it's necessary, but I'll go over MCQ first. So let's talk about, and I'm only go over this particular question that is more difficult. So I'm gonna go to that. Should I give you answers or no?
Please, please, he needs to know what I got wrong.
What?
Like, I'm like 18. I need to know what I got wrong.
You not tell people like what should they go wrong?
I can tell you which question you got wrong.
You want me to look at the answer?
No, I want to see which not the answer. I want to see
Yeah,
which
yeah,
I got wrong.
yeah.
So I can read that.
All right, so I can do that.
I want to know what I did wrong.
You don't want to know the answers, right?
No, just like what questions I
No,
gotta
you
read.
need to work on it yourself.
Like,
Okay, so you can you can take a picture of the zip code here. You just have to find your name. Review paper, you just have to find your name and then you click it on your skin. You can see which question you got wrong.
thank you.
If you need to do that, you can come here do that.
This,
It's a long list, right?
Yeah. There's Umar, so I'm near.
Damn, it's all red. It's all red.
I'll bounce back. I was telling, I don't know who I was telling. I'm like a trampoline, monsieur. The springs are too tight.
Okay.
Thank you.
There are two type of people, Omar.
Yes.
People talk shit and those people do shit. You have to find your name and click into it. You can scan. You can see it.
Yo, why did I say that? Why did I say
Just take a picture of it. Oh my god.
Thank you.
Yeah, I got
Is it by date or grade or
My name. Oh no, you write your name. I didn't write your name. See that name has on it. You can take a picture of that. You can know what question you got.
Yes, dude. Holy sh. Oh, wait. It's EY equals plus C.
You need to do better.
One is my answer sheet.
What? What did you say?
I bubbled on my answer sheet, but I bubbled a different answer.
I think it's C. It's like yeah, EY equals EX plus EX. And then there are the easy algebra so the Y is or not X plus
All right, so yesterday I choose to go over this particular question. So I'm gonna go over this one because I think this one's more, is it better than any other questions? So this is the question, right? I'm gonna choose to go over this one. This one is, it's only worth 1.2 in MCQ, which is kind of sad because this question is actually very difficult. It should worth 7 points. They should put this one on the FRQ, but then probably a lot of people would get it wrong because a lot of people won't start the first step. So we are talking, why did I choose to go over this one? Because this one, they can choose to say it's the rate of change. How many of you guys got this one right? Question 25, did you get it right? The answer is C. Okay, so on my BC calculus student, a lot of people score 40. A lot of people. Like we were talking about Marcos, Charlie, Amil, they all score roughly 40. But they all got this question wrong because they are AB question, but this is, everybody got this one wrong. So it's a very hard question. The first difficult part is the dy dx is equal to e to the x times e to the y because a to the m times a to the n equal to a to the m plus n. Do you guys know this? This is just basic exponent rules. Now I'm gonna separation the variable. On AP exam, you need to do it one step at a time. So in order to avoid the mistakes, I will multiply dx on both sides and I move the ey to the other side. So dy over e to the y equal to e to the x dx. Now I'm gonna integrate them. If I'm integrate, how many of you guys know how to take integrate of dy over ey? Yes, Omar. No, you failed. I'm glad you failed because that's what most people do. I know you know. Rayhan, what do you do with dy over ey? How do I integrate that? You were right. Negative exponents. I don't know who. Did anybody help him? Okay, so negative exponent. Why? Because you move to the top. And then you can do u substitutions. Because integration of e to the u, this one's going to be negative du equal to integration e to the x dx. Why? Because you cannot take an integrated with natural log. Natural log is 1 over x, not 1 over e to the x. So then that's going to be negative e to the negative y equal to e to the x plus c. Now for me, I want to solve for y. But before I get to y, I must get rid of the negative sign. So e to the negative y equal to negative e to the x plus c because c is not changing. I'm going to natural log both sides. So natural log e to the negative y equal to natural log of negative e to the x plus c. And that's going to give you negative y equal to natural log of negative e to the x plus c. Y is equal to negative natural log of negative e to the x plus c. Now, obviously there's an initial condition because they told you initial condition is y0 equal to negative natural log of 4. So I'm going to plug in natural log of 4, negative equal to negative natural log of negative e to the x plus c. Now this one's going to be 0 if I plug in 0 here. So that's going to be negative natural log of 4 equal to negative natural log of negative 1 plus c. C has to be 5 because 4 is equal to negative 1 plus c. C is equal to 5. So therefore, I replace this with 5, and I'm done. And this, my equation, C is the right answer. Now this only with 1.2 points, which is crazy. So much math. It's only 1.2. Nobody got it right. BC did not get it right. AB did not get it right. Avadash did not get it right. Avadash got a higher score. So everybody got it wrong. Very good questions. And this on FRQ, 6 points. You're gonna be, yes. I don't know. Sure.
No, dude. You can cancel it out of the curve. You cancel, you still have a hole. You eliminate that. You have to consider the fact that even after you cancel, there's still going to be a hole.
Wait.
And the numerator is not a whole line. There's no way to show y now.
What do you mean?
Like, you know, we only have the denominator is
And
0.
then the numerator is 0.
What were we? Okay. So
Anybody else need to find out whether they're wrong? Is you can come in, click here and take a picture of what you got wrong. So number 9, somebody want me to go over? I'll go over continuous. So let's just say if you cancel this one, let's just say you cancel this one, you cancel one of them. So that's gonna be x minus 2, x plus 3, and x plus 1. But like what Nathan says, there's a hole if you cancel. That's still not continuous. So x equal to 2 is not continuous. And x cannot equal to -1 because that's a vertical asymptote. So it should be 2 and -1. Is that D?
8, 9, 10, 12, 14, 15, 16, 12, 14, 15, 16, 18, 20, 24, 25, 26, 27, 28, 24, 25, 26,
Because if you cancel, it's still a hole.
31, 36, 38, 40, 42, 45. Alright, tell me which one is that one. Wait, this is not yours.
There's 40.
This is someone else's, bro.
I have the graph.
Did you seriously do that?
And the like, it's asking for relative extremely. So it's the 0
did already do
of this
this.
prime that go.
No, wait, you got the same
Negative,
ones wrong.
positive, they
3,
changed
4,
it.
5, 8, 9, 10,
Positive to negative,
12,
negative, positive.
14,
Yeah, yeah,
15,
yeah.
16,
And the only thing I was confused about. I got put 5. I got 1, 2, 3, 4,
30,
5.
Okay,
31.
graph let's don't
You got
make.
32
Negative
wrong.
4
You got
to 2.
32.
So you have too many things going on.
Just start by making
You
3,
can
4,
set
5,
x min and x
3, 4,
max
5,
to
8, 9,
negative
10,
4 to
12,
5, 8, 9, 10.
12, 14, 15, 16,
window,
So,
x
18,
min,
20,
negative 4.
24, 25, 26, 27, 28, 30, 31, 32, 35, 36, 37,
But I know this one doesn't go
39,
over,
40,
I zoomed in it.
45. 45. You got 42 right. 45 is wrong.
It's like 3 decimal points.
1, 2, 3, 4.
You got 42
5,
right,
6.
bro.
6.
Now,
Where do you get 6 from?
let me borrow your
If you
pen.
say this 1, 2, 3, 4, 5, 6.
Oh, if it goes.
You cannot count.
This is my
No, I
1,
can't.
2, 3, 4, 5, 6. I can let you borrow a finger, so you have no finger.
Are you serious? I counted that one. I didn't see. Ah, that's rigged. That's stupid.
No, you're just blind.
Look how much of the zoom in.
You're just blind.
4, 5, 1.
You're blind. You is blind.
5, 6.
Remember that. That thing. That thing.
I wouldn't be talking. I wouldn't.
11, 12, 13, 14.
No, do you see the clip I sent you?
13, 14.
It was like Chris Tucker
17,
and
18, 19, 20.
Chris Tucker and some Asian guy.
Yeah.
He's like, you
All right,
blind.
22.
No, you blind.
20 and 22.
20, 30, 25, 26, 27, 31, 33, 35, 36, 37, 38, 39, 40, and then 42, 43, 44, 45.
You got a lot to go over.
Where's my pen, bro? What's on my pen?
This X plus 36. Well, I corrected it again. I did. Yeah. Wait, did you get 4? For 12? Yeah, I got
That was wild. Picture, yeah. Can you go for 12?
Sure. You gotta find your name and then click into it. Okay, question 12 is fairly easy. If you reach infinity, the first one's gonna be infinite over infinite. So if it's infinite over infinite, you just do L'Hopital rule. So if you do L'Hopital rule here, it's 1 over x, and this is 99x to the 98. Well, that's just gonna be 1 over 99x to the 99. And if it goes to infinity, that's going to 0. So that's 0. The second one, if you do infinity, that's infinity over infinity, so it'll be e to the x over 1 over x. So that's going to keep change flip, so it'll be e to the x times x. Now, if I go to infinite, guess what? It's infinite. So the last one is the hardest one to tell. Because the last one you can take, if you do L'Hopital rule 99 times.
You're gonna get 99 factorial over infinity.
99 factorial over e to the x.
That's equal to 0.
99 factorial is a huge number. If it's in meter of 99 to the thing, I don't think you can go pretty far. Okay? I don't know how far that goes, but the number doesn't even comprehend that. So it's huge number. I don't know to which power it is. I don't even think your calculator can calculate 99 to the factorial. Does it? No, right?
So how did you know to do L'Hopital just one time?
Because you got infinite over infinite, that's indeterminate form. And this is equal to 0.
Factorial over infinity?
Yeah, because on the bottom still gonna be e to the x. Because I take a derivative top and bottoms 1 over x over 99x to the 98. If I go to infinite, that's gonna go to 0 because the x becomes the bottom. Next questions. You have to find your name, click into it, and then you can see which question you are. Alvin, what'd you get? 31?
Yes, bro. I want to actually
Huh? That's kind of weak.
Yes, I wrote one because I also canceled off the bottom, so oh, it doesn't exist anymore.
It does exist, it's just a hole. You have to find your name, click into it, you see it. Kevin, shut the hell up, get to work.
Remember how to clean your oven?